Hi, welcome again. We closed the last episode with an interesting situation. The situation is just a fictitious tale because I need a premise to explain a possible strategy to incorporate changes into a working program. That is the theme of today's session. Let me assume that we got an opportunity to install many such client tender missions across India, but the requirement involves an interesting customization to this client tender mission. What is that? In order to salute our great scientists and to create awareness about their stellar contributions to the advancement of science, the government of India plans to mint coins to commemorate their birthday. Aside from minting coins in smaller subdivisions in large quantities, we increase the frequency of remembering these great scientists and hence their works. As before, I illustrated them in the same decision table for your reference. If it is a coin or flipping of a coin, we should start with Satyendranath Bose. Do you know why? Let me leave it to you to discover. So we have Bose, C.V. Raman, Vikram Sarabhai. What this 12, 7 and 1 are? This is the day of their birth. Satyendranath Bose born on 1st January, so I put 1 here. C.V. Raman's birthday is 7, and our Ramanujam born on 22nd. It goes like this. You can check that with Wikipedia later. So, what the twist now? For example, if the input is 1, we have to print B followed by best wishes from Bose. If the input is 19, 19 is V, that is 12, that goes to V, and the balance 7 will be utilized for this slot, C.V. Raman slot. So it will print VC after a space, best wishes from C.V. Raman. So this is the interesting requirement I have created. So now our objective is building a coin tender mission in such a way that it should be customizable for the individual needs. And how to introduce the change? The dream of a programmer or every programmer aims for their code to be elegant and efficient. We will discuss later what we mean by an elegant and efficient code. The golden words of Bjorn Stroustrup, the inventor of C++. Now, the code is great, but it is not allowing me to make changes. It's more a rigid code now. So the culprit for that is this get slots, that what we did in the previous session to make the slot to give a vector of slot. So this is a clear violation of, or it's a clear indication that we put this at a wrong place. So what we can do now is we'll try to inject the slots into this method. So how about we are um, giving the slots to this method rather than asking this slot to produce its own slots. I mean, asking this method to get its slots. So I'll go to the features now. What I want is, I want to have this vec params are written with pencil and rubber, so we can change this at any point in time. And this complaining about the slot, and just you can leave it like this, vec okay? Because we want the slot, and the slot is again in the machine.rs. Let us ask for the slot, and the slot is not visible outside. We'll make the test. Now the method new, the associative function new is associated function new. See this word associated function. We'll again discuss this later. What is an associated function shortly, and what is not an associated function. This is a private one. So now we have the slots, and one way we can do is we can inject slots here. But this will call for a change to the API. It's inevitable because the code that what we wrote yesterday is not an elegant and efficient code. It is just a half. It's a code that served its purpose to some degree. Today we will make this code to pass this slot as a parameter to this. Another idea is that we can put this in a different method and make that method to call internally the exchange for method. So meaning, if you still want to preserve this exchange, the signature of exchange for as given input, we can do that in a different way. We'll do that shortly. Now let us try to experiment with what are the various possibilities and the reason about the downside of doing or practicing certain kind of a programming patterns or selecting certain kind of a programming patterns. This is going to accept slots of type vec slot, or the other way of doing this is we'll do that later. Then we'll ask Eclipse to give us some suggestion. Some good thing that time permits will go through. And we modified our test case to offer the slots. So we don't want the slots to be here, and this is one way of so the main, the place where we invoked this, that again needs this. So we are passing the dependencies to all possible layers. That's not a nice approach. but it is inevitable for this given scenario. This is an example of how we should not write a code. Now, see the various places I am impacting because of a poorly written exchange for. A simple mistake that what we did some 2 days before is coming as a blockade for us to make any modification to this. So now what are the other things we have? The main is pausing. Slots. Use of moved value. What is that? This is the famous Rust suggestion for us. It's not an error, as I told some 2 sessions before. We are passing the slots, the vector of slots here. So this value is moved and we cannot use this again. So the reason why Rust is giving this restriction or offering this or ensuring that there should not be any data erasing situation. So what will happen if the slot is given to this and if it has been if another person is also attempting to use the slots, and that will lead to a lot of data erasing situations. So what Rust is doing is they introduce this a great principle. What is that? The ownership and borrowing rules. So instead of I'm passing the slots, which is a vector of slots altogether into this method, what I can do is I can make the signature of this method, the machine, to accept the address of this. In other words, the slots is let me show like this. This equivalent of now the second suggestion is, what we are actually doing is we are not passing the slots, that is we cannot pass the complete ownership of the slots to this method. Rather, we have just passed or we have just made this exchange for to obtain or to borrow this. So we have just passed the reference of this, not the actual slots. The slots is a reference to this US slots. Another way of doing this, in case if you want to remove this method, the line, can pause it like this, and the best way to do that to avoid lot of keyboard strokes, the slots will be the reference to the US slots by using this ampersand symbol. Now the message we got is try using a conversion method slots.toVec. That is one idea to do this. Another way to do that is go to the machine and obtain not the vector of slot, rather you obtain the reference of the vector of slot. Now let us use the same philosophy here. Let us ignore the main for the time being. We'll just focus between the features under the machine. So if we had to make this method to accept an Indian slot, what is an Indian slot? This is an US slot. We'll make this as should dispense US has. We'll write one more method. Let's ignore this particular requirement for the time being. We'll first provide the slots in the decreasing order of the scale. That is, B is the smallest subunit. So when we create the slots, we create the slot and we stack that with the highest value coming first. So Homi Baba followed by Satish Dhawan Ramanujan. So what is it? Let us just to take these two things. So H is 30 and Satish Dhawan 25. Ramanujan 22 and 12, 7, 11, 1, 7, 12, 22. And as well, 7 is for Sivaram. Vikram Sarabhai, Ramanujan, Satish Dhawan, Homi Baba. Let me pause this 97 to check whether I am expecting this H, and C. So it equals exchange for 97. The slot is a reference hereafter. Slots. What I get, my expectation is this is giving us a result. So it's not complaining with any others. found str. Try using a variant of this expected enum. So the suggestion for us is exchange for 97 is returning a result. We are comparing this against HHHC. So either we can unwrap as we did that here. Otherwise, let us try to do that something differently. Okay. Because we can of course compare something like this as well. Because the value that it returns is OK of some string. Let's try. This is again not a string. Let us check whether it is converting it. Okay. Expected struct string found ampersand str. But if provide unwrap here, the conversion happens automatically. So the test passed, but we have not yet met the requirement. The requirement is having an interesting twist. Twist make the life of programmers very interesting. That's what we are going to do today. That's our idea. So we will just reason about what we did so far, and also you try to find why we are unable to put this OK. Okay, we'll show that to you. OK. You can do an assertion like this. This is more versatile because the test tells you when I ask the method exchange for, it should give me a result, and I'll check this against OK. But what I'm expecting out of this is not actually an ampersand str. Rather, this is a string. So how to make this into a string? One thing what we can do is we can put this as to won't, for example, and this will make this the result HH as it is equivalent of to string also. We can do that in several ways. So if we do the assertion now, you can see that it is passing without any errors. So this is a more but it's a better way of doing or testing a result rather than unwrapping that and checking that again P. It's okay. But here you are learning something. The conversion is happening automatically. You are not actually checking this against dot to string, because the asset EQ method having some tricks there to make the coercion possible.